No, you are not allowed to pull all number 10 American wire gauge conductors in one raceway without dirting or voltage drop calculations. According to the National Electrical Code Table 310.15 CON, the maximum number of conductors permitted in a raceway is 3 for conductors larger than American wire gauge 8. Therefore, the 3 number 10 American wire gauge conductors would need to be separated across 3 different raceways. Let's break down the reasons why this is the case, addressing both ampacity dirting and voltage drop considerations. Firstly, consider ampacity dirting. When multiple current-carrying conductors are bundled together in a raceway, the heat generated by each conductor can raise the overall temperature within the raceway. This increased temperature reduces the current carrying capacity or ampacity of the conductors. The National Electrical Code addresses this issue by requiring that the ampacity of conductors be derated when more than 3 current-carrying conductors are present in a raceway. National Electrical Code Table 310.15 CON provides adjustment factors for different numbers of current-carrying conductors in a raceway or cable. In your scenario, you have 3 30-amp, 3-phase circuits, which translates to 9 current-carrying conductors, 3 for each circuit. With 9 current-carrying conductors, the ampacity of the number 10 American wire gauge conductors must be reduced. The specific dirting factor depends on the insulation type and the ambient temperature, but it will significantly reduce the allowable ampacity. Number 10 American wire gauge conductors typically have an ampacity of 30 amps at 60 degrees Celsius, 35 amps at 75 degrees Celsius, or 40 amps at 90 degrees Celsius, depending on the insulation rating. However, once you apply the dirting factor for 9 current-carrying conductors, the allowable ampacity will likely fall below the required 30 amps for each circuit. This means that the number 10 American wire gauge conductors would be undersized for the load, posing a safety hazard. To determine the exact dirting factor, consult National Electrical Code Table 310.15 CON. Locate the row corresponding to the number of current-carrying conductors in your raceway, which is 9. Then find the corresponding adjustment factor. Multiply the initial ampacity of the number 10 American wire gauge conductors by this adjustment factor to obtain the derated ampacity. If the derated ampacity is less than 30 amps, you must either use larger conductors or separate the conductors into multiple raceways. Secondly, voltage drop is also a critical consideration. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, overheat, or fail prematurely. The National Electrical Code recommends limiting voltage drop to no more than 5% for feeders and branch circuits. For a 208-volt circuit, a 5% voltage drop would be 10.4 volts. Therefore, the voltage at the equipment must not be less than 197.6 volts. The voltage drop in a circuit depends on several factors, including the conductor size, the conductor length, the current flowing through the conductor, and the conductor material. Smaller conductors, longer distances, and higher currents all contribute to greater voltage drop. To calculate the voltage drop in your scenario, you can use the following formula: voltage drop equals 2 times K times I times D divided by circular mils, where K is the direct current resistance factor for the conductor material, which is typically 12.9 ohm circular mils per foot for copper. I is the current in amps. D is the one-way distance in feet, and circular mils is the circular mil area of the conductor. For number 10 American wire gauge copper conductors, the circular mil area is approximately 10,380 circular mils. Plugging in the values for your scenario, with a current of 30 amps and a distance of 190 feet, the voltage drop would be approximately voltage drop equals 2 times 12.9 times 30 times 190 divided by 10,380, which equals approximately 14.15 volts. This voltage drop of 14.15 volts exceeds the recommended 5% limit of 10.4 volts. Therefore, using number 10 American wire gauge conductors for the circuit would result in excessive voltage drop, which could negatively impact the performance of your Woodshop machines. To address the voltage drop issue, You have two main options. You can increase the conductor size or you can reduce the circuit length. Increasing the conductor size will reduce the resistance of the conductor, thereby reducing the voltage drop. For example, using number 8 American wire gauge conductors instead of number 10 American wire gauge conductors would significantly reduce the voltage drop. Reducing the circuit length will also reduce the voltage drop, as the voltage drop is directly proportional to the length of the conductor. However, in your scenario, the circuit length is fixed at 190 feet, so this may not be a feasible option. In summary, running 30-amp 3-phase 208-volt circuits using number 10 American wire gauge wire in a single raceway for a 190-foot run is not permitted due to both ampacity dirting and voltage drop considerations. The number of conductors in the raceway requires ampacity dirting, which would likely reduce the allowable ampacity of the number 10 American wire gauge conductors below the required 30 amps. Additionally, the voltage drop calculation shows that the voltage drop would exceed the recommended 5% limit. To comply with the National Electrical Code and ensure safe and reliable operation of your Woodshop machines, you must either use larger conductors or separate the conductors into multiple raceways. Consider using number 8 American wire gauge conductors or running each circuit in a separate raceway to address these issues. Always consult with a qualified electrician to ensure that your wiring practices comply with all applicable codes and regulations. They can help you determine the appropriate conductor size and wiring methods for your specific application. Furthermore, proper grounding is essential for safety in any electrical installation. Ensure that all equipment is properly grounded to minimize the risk of electric shock. Grounding conductors should be sized according to the National Electrical Code Table 250.122 based on the size of the overcurrent protection device. Finally, remember to always de-energize circuits before working on them. Use appropriate lockout-tagout procedures to prevent accidental energization. Electrical work can be dangerous, so it is essential to take all necessary precautions to protect yourself and others. By following these guidelines, you can ensure that your Woodshop machines are wired safely and correctly, providing years of reliable service. The National Electrical Code serves as a comprehensive guide for electrical installations, promoting safety and preventing electrical hazard. Adhering to the National Electrical Code requirements is crucial for protecting people and property from electrical fires and shocks. Always consult the latest edition of the National Electrical Code and any applicable local codes before undertaking any electrical work. Furthermore, consider the environmental conditions in your woodshop. If the ambient temperature is high, you may need to further direct the ampacity of the conductors. Also, if the environment is dusty or corrosive, you may need to use special types of conductors and raceways that are designed to withstand these conditions. Proper planning and attention to detail are essential for a successful electrical installation. Take the time to carefully consider all of the factors involved and consult with a qualified electrician if you have any questions or concerns. By doing so, you can ensure that your woodshop is wired safely and efficiently, providing a safe and productive working environment. Remember that electrical codes and regulations are subject to change, so it is important to stay up to date on the latest requirements. Consider attending continuing education courses or seminars to enhance your knowledge of electrical safety and best practices. Investing in your knowledge and skills will not only protect yourself and others, but also improve the quality of your work. Ultimately, the goal of any electrical installation is to provide a safe and reliable power supply for the equipment and appliances that depend on it. By following the National Electrical Code and using sound engineering principles, you can achieve this goal and create a safe and productive environment for everyone.